Hello, my name is Newman, and today I'll be presenting our paper titled On the Generation, Structure, and Semantics of Grammar Patterns in Source Code Identifiers. This paper was accepted during the summer of 2020 by the Journal of Systems and Software. This work was done by myself and the members of the Scannel Lab. Scannel Lab focuses on source code analysis and natural language problems. It was founded by myself, Reem AlSuhaibani, Michael Decker, and Emily Hill. It had several members that are on this paper: Anthony Peruma, Tehal Vishnu, and Satyajit Mohapatra. In addition, this work was done in collaboration with Dr. Mohamed Mkaouer of the Smile Lab. All the data that we will present to you today is available through our webpage that you can see at the bottom of this slide, scannel.org. If you're interested in reading more of this paper or using the data set, please visit that webpage and you'll find everything there. As you may have guessed, the topic we're dealing with today is identifier naming. Weak identifier names make it harder for developers, as well as automated approaches, to understand what the code is doing. So even machine learning or artificial intelligence techniques that use identifiers as part of their data are vulnerable to being misled by poorly named identifiers. In this paper, we use part-of-speech tagging to help us begin addressing this problem. Part-of-speech taggers are designed to annotate a word with a category that informs us of the word's role and the context of other words surrounding it. In this case, this context must also include the code. We use the term grammar patterns to refer to part-of-speech sequences generated from the words that constitute identifier names. You will see an example of grammar patterns soon. The goal of this work is to use grammar patterns to understand more about how words and the identifiers that these words are part of convey linguistic semantics and code behavior. To achieve our goal, we manually annotated 1,335 identifiers with part-of-speech tags. These identifiers were drawn from 5 different code contexts: function, declaration, parameter, attribute, and class names. We performed a qualitative and quantitative analysis of both frequent and infrequent, but meaningful grammar patterns so that we could get a diverse picture of how grammar patterns reflect linguistic semantics and code behavior, even in the case that a given grammar pattern is not frequently used relative to other patterns. In addition, we report on the accuracy of techniques that generate grammar patterns, since these are a prerequisite to using grammar patterns in a scalable fashion. We use the following tag set for our manual annotations. This tag set is more comprehensive than the tag sets used by the source code-oriented part-of-speech taggers that we studied. It also includes some tags that are typically not found in part-of-speech taggers for normal human language documents, specifically pre, which stands for preamble. So what are preambles? To give an example, some languages like C do not support the concept of namespaces. A preamble, among other things, is a word in an identifier used for namespacing purposes. There are a few other types of words that we also consider preambles, but we won't go into depth about them in this presentation, as they are not needed to understand the rest of what we have to say. Please refer to the paper for a more formal and thorough treatment of preambles. The other tag to notice is Noun Modifier, abbreviated N as in not and M as in mother. Noun modifiers are either normal adjectives or noun adjuncts, which are defined as nouns that are being used as adjectives. We'll see an example of this in a moment. Grammar patterns are created by splitting identifiers into their constituent words and then running these words through a part-of-speech tagger as if they were a small sentence. We have 4 different patterns in the examples below. The first is a verb phrase. The second is another verb phrase, but with a preamble, which is functioning as a namespace. The third is a plural noun phrase, and the fourth is a noun phrase with a determiner at the beginning. Recall that we highlighted noun modifiers a moment ago. Noun modifiers are typically noun adjuncts in source code. That is, they are nouns that are being used as adjectives. In the examples on the slide, we see noun phrases like platform window surface and DMF header. The words platform and window are noun adjuncts. They describe the kind of surface that this identifier represents. DMF describes the type of header that its own identifier represents. An easy way to see this is to put a dash between the words. For example, DMF-header. It is common to mistake these for regular nouns, but the correct annotation for these is noun adjunct. Modern taggers make this mistake a lot when annotating identifiers, as we will see soon. We analyzed the accuracy of 2 part-of-speech taggers designed for code, Swum and Posse. We also analyzed the accuracy of one tagger built for normal text, Stanford tagger. We analyze the accuracy at both the word and identifier levels. Unfortunately, we will not be able to go into great detail here due to time constraints, but in summary, Posse and Stanford had around 10 to 27% accuracy at the identifier level, while SWM had 50 to 68% accuracy. With respect to word level accuracy, Stanford annotated more types of part-of-speech annotations correctly than the other two taggers. In all, we found that there's a lot of synergy in the strengths and weaknesses of the individual taggers. Please refer to the manuscript for more detail. We now summarize our analysis of grammar patterns. There were 3 grammar patterns that were extremely popular, appearing in the majority of other larger patterns. Thus, we focus on these and encourage you to find the rest in the manuscript. From here on, plus means 1 or more and star means 0 or more of the token to the left, just like in regular expressions. The first pattern is a noun phrase pattern. This is 1 or more noun modifiers that specialize the meaning of a head noun. The head noun of a phrase is typically the rightmost noun in the identifier and is representative of the in-memory entity that the identifier refers to. Some examples of this are given on the left: layer, parameter, and driver type name. In these examples, the words layer, driver, and type are used to help us understand the head nouns, parameter, and name. The next pattern is the verb phrase pattern. Verb phrases are defined as a verb followed by a noun phrase. Typically, verb phrases represent function names, but we and other researchers have also found that there is a correlation between identifiers of Boolean type and the use of a verb in the corresponding identifier's grammar pattern. The verbs specify the actions that these functions will take, whereas the noun phrases describe the object that these actions are applied to. The last pattern is a plural noun phrase, which is just a noun phrase where the head noun is plural. The existence of a plural in an identifier name is sometimes purposeful. Our data suggests that there is some correlation to the use of noun plurals for identifiers with list types, but it is not a strongly consistent pattern. Further research is needed to determine whether and when the use of a plural in an identifier with a collection type is appropriate, and if identifiers with collection types but no plural in the name are some form of linguistic anti-pattern. We also note some common mistakes made in annotating identifiers. Most taggers annotate noun adjuncts as pure nouns, as seen in all 3 examples in the table. In addition to the most frequent patterns, we wanted to explore the diversity of grammar patterns that we found. On this slide, we present a few of these patterns that, while not the most frequent, were nevertheless seen in multiple systems and representative of different types of code behavior. The first pattern is a prepositional phrase pattern with an optional noun or verb phrase preceding it. Based on our data, prepositions are typically used to understand the relationship between the phrase on the left or the right of the preposition. Type conversion code, for example, follows prepositional phrases and identifiers such as angle in radians, int to string, and depth stencil as texture. Sometimes the convert is explicitly stated, as in the identifier convert to PHP namespace. Event and handler code also follows a prepositional phrase structure, such as in the identifier on key press. The second pattern on this slide is a determiner followed by a plural noun phrase and optionally preceded by a verb. The meaning of identifiers following this pattern tend to be specifying the population that they represent or are interested in. For example, all invocation matchers has the determiner all in its name. The word all implies that this represents a list or is a method containing a list, where the population of that list is all of the invocation matchers. This is the same for the identifier all factors. All is not the only determiner that we found. The word any is also used, where any helps us understand that there is at least one parent category, in this case, in a list of some kind. Another common determiner is the word no, where we specify that we want none or not any of an object in some population. Again, more of these can be found in the manuscript. In conclusion, grammar patterns are an effective way to highlight and analyze similarities and differences in the way identifiers are used in code and linguistically. However, we need stronger tagging technologies so that it's easier to perform analysis using grammar patterns. In particular, taggers need higher accuracy with noun adjuncts, plurals, adverbs, conjunctions, and preambles. Our future work involves building a part-of-speech tagger based on our data, improving identifier naming using grammar patterns, and analyzing other types of identifiers such as test identifiers using grammar patterns. Please visit our webpage for the dataset we use in this study or to see other work done by Scannell. Thank you very much.